Cool. Awesome. So welcome to the May edition of the Utah Data Engineering Meetup. So we've been, close to 2 years running now. Next month will be the 2-year mark for this meetup. So glad you all could all participate, keep the movement going, I guess. So let's look at here. So today we have Taylor Miller, who's going to talk about something that I think is pretty cool. This Python package called Great Expectations. It's a data quality tool. I'm sure Taylor will explain a lot more about it in a second. But yeah, when you mentioned he was working on this, I think it was a while ago. It sounded like a very promising project, and it seems like it's got some legs. So very excited to hear about this. We usually do a who's hiring and who's looking before we kick things off. Is there anyone out there who's hiring right now? If so, feel free to chime in on audio or leave a note in chat. Is there anyone hiring right now?
Hey, Joe, this is Matt. I'm with Finicity, and we're actually hiring a bunch of people right now, but we're looking for data engineers, DevOps, Java, Node.js engineers, and doing some really cool things in the fintech space. And recently announced that we're a founding member of Trust Over IP, which is a Linux Foundation project, which is something really cool. But if you'd like more information, let me know. Or anyone else. I know there's some other Finicity people here on the call, but we're definitely looking for some people.
Cool, awesome. So that's Matt Davies, really cool guy, and yeah, Finicity's a great company. So thanks, Matt.
Yeah, thank you.
Yeah, of course. Anyone else? Yeah, it's crazy. Like back in, it's funny comparing this to February's meetup where everyone was hiring and I think nobody was looking. It's interesting to see what's happened in the last couple of months. So I know Overstock is hiring as well, and there is. I'll post it in the chat during the talk. But I know there's a big Airtable report too. That's like 7,000 companies, and it basically gives a list of like who's hiring, who has a hiring freeze, and who's definitely not hiring. So that might be a good resource for the next question, which is anybody looking for work? If you are, feel free to maybe give a quick plug about yourself or put it in chat. I
got a plug.
Okay, go for it, Angel.
Yeah, so I'm personally actually not looking for work, but my little brother is. He just graduated with master's in business analytics, and yeah, he's in the Python AWS stack. So if anybody's looking for early career guy who's a good he's a good guy. I mean, I'm biased, but yeah, I'll definitely be interested.
Awesome, cool, thanks, Angel. So Angel's brother is looking for work, so hit him up. Anyone else? Cool. Right. Well, if you are, there's also there is a looking for work channel in the UDEM Slack as well. So if you're up for posting there, don't be shy. Totally get it. You know. So upcoming events. We have sorry, a couple people are joining here. We have SLC Python on June 3rd. I'm not sure what the topic is yet. In our usual fashion, we'll probably figure that out the day before. So stay tuned on that because we're super organized with that meetup. The SLC Google Cloud meetup is on Thursday, June 4th, and that's going to be awesome. We got Carson Anderson from Weave, who will be talking about secret management and Kubernetes. So if you're not familiar with Carson, I think at what was it, the Cloud Native Foundation talks, I think his talk actually is #1 right now, beating out Kelsey Hightower, for example. So like pretty heavy hitter guy. That would be a good talk to check out. And then finally, June 17th, we have the next Utah Data Engineering Meetup with Dave Langer out of Montana, actually. So he's going to be talking about data literacy. So that's going to be a good talk. We already have quite a few registrations for that. So stay tuned on that. Are there any other events that I haven't posted here that you want to give a shout out for? No? Okay. Oh, and I think tomorrow, actually, what I forgot to mention was the Utah Java Users Group has Venkat. He's going to be talking, I think, about Vue, React, and Angular. So if you haven't heard Venkat talk, just sign up for that experience alone. The guy's a phenomenal speaker. So, and if you want to give us a talk, we're always open to new suggestions. Post it on meetup.com or message an organizer like myself or other organizers on Meetup. And we do have a Slack group. If you're not a member, become a member. And then some ground rules for the virtual meetup. So mute yourself unless you're talking, which you all are doing a fine job of. Looks like everyone's muted. For Q&A, I think the way Taylor wants to do it, he's going to maybe have some slides where he kind of pauses and asks for questions. Feel free to ask him there. Chat's another good spot. We'll do our best to work through those. And if you don't need video, turn it off, just to save yourself some computer space. So with that, I'll turn it over to Taylor. So I'm going to stop sharing and let him get queued up. So
right on. I just want to put in a plug for that Venkat talk. He is a phenomenal speaker. Doesn't matter the subject, just go see him. It's phenomenal.
Yeah, I mean, he could talk about probably like
anything.
Vacuuming floors or something. It would just be a great talk. I mean, so.
Absolutely phenomenal. All right, I'm going to share my screen here in just a moment. We're going to get going. Okay, you should see a browser, and we'll get some slides here in just a second. Let me know if you can see it. So I'd love to have this be as interactive as possible with a virtual meetup. So let's dive in. So throw messages in the chat. Jump on audio. I do have a couple places where I'm intentionally pausing to talk about questions and so forth. And we're gonna have some really fun live demo. All right, so let's dive in. So I'm Taylor. I'm from a company called Superconductive. We started out as a data consultancy, mercenaries for hire, and really focused on data quality with all our projects. We did a lot of work in the healthcare space, and we had this open source package, kind of a side project that was started by two excellent engineers and data scientists. And we didn't really invest in it and just kind of let it sit there. We'd use it in some client projects here and there. And without doing anything at all, it started to become popular. And we so much that we kind of gave us pause, and we started to think about this, like, so maybe everyone has a data quality problem, and we should really double down on this. While I'm mentioning that, I've got a link I'm going to put in the chat. So I've got a few links here. The one I would like you to look at first is, if you have a scary data story, throw it in the Google form. And it's anonymous, please don't post anything that would get you in trouble, but we'd love to chat about a few of those after. And if there's, I will be picking one at random, and we will send you a little bit of open source swag. So throw that in that link. Let's get back to the slides for a minute here. All right. So this project started to get really popular, and turns out everyone has a data quality problem. So last summer, we really doubled down on this, and we reorganized the whole mission of the company. And now we have, depending on the day, 4 to 5 to 6 people working full time on Great Expectations. And then we have another side of the company that helps companies implement Great Expectations and best practices and so forth. So what are we going to do tonight? So 3 things. We're going to have a good, sobering look at something that we do as data engineers that is just absolutely crazy. We're going to look that in the eye and have that really deep conversation. We're going to learn about how to crush pipeline debt, and then we're going to have a lot of fun with a live demo. So let's jump right in. Okay, so imagine I am a software engineer. I come to you and I say, oh, I have got this piece of software. It is just so powerful. It's going to answer all your questions. It is going to change your business and in so many ways. By the way, it's not documented, so you're going to have to figure out how to use it yourself. The APIs, I mean, they're there. You can find them. But it's not documented. Oh, it's also not tested because, you know, we don't have time for that. And by the way, it's unstable. The APIs might change, and we don't even know when they'll change. So good luck. Now, you would hopefully laugh me out of the room, leave me bad Yelp reviews, and never talk to me again, right? Now let's change one word and one character in this story. So instead of me as a software engineer trying to sell you a piece of software, here's me as a data engineer. And I say, hey, business person, here is this new analytic data. Here's this new warehouse, you know, whatever it is, here's this new data product. And it's going to change the way we do our business. It's going to save us money, new customers. The world is going to be better. Oh, by the way, it's not documented because, you know what? Data documentation is really hard. It's hard to keep it up to date. If you look around the wiki, there might be an old data dictionary. So, you know, good luck. It's also not tested because that's really hard. And, you know, we've got other reports to make. So back to my reporting. One more thing. It's not stable, and which means the meaning of the columns might change. Some fields may appear or disappear. Yeah. But yeah, you should use this data. It's really going to be a game changer. Now, here's the part where we look ourselves in the mirror as data engineers and we say, wait, I would have laughed the software person out of the room, but this is what we call normal life in data engineering. This is how we work. And this is just crazy. We've got to deal with this a different way. So we have monsters in our pipelines. And these monsters we call pipeline debt. You know, very analogous to tech debt, but pipeline debt has a particular flavor and comes in a particular way. So we've made all these comparisons of pipelines and software. And pipelines are software, but they're also not like software. The biggest difference really is that when you introduce a bug in software, you can get blame and find out that it turns out that bug is your fault. Those were your failures. In a pipeline, oftentimes when you find bugs or surprises, those are created not necessarily by you or your team. They're often created by the data creators, and that may be user-generated data. It may be data from a vendor. It may be who knows where the data came from. But it's the data flowing through your pipelines that often causes you trouble. So instead of testing the code, we really want to test the data because that's what gives our pipelines life. And we want to run these tests not when we build our pipelines. I mean, we should, but we also, more importantly, want to run those at batch time, at runtime. As that data is flowing through our pipelines, we really want to run those tests. Okay. This sounds like a lot of work. Why would we test our pipelines? Well, it's all about risk mitigation. We'll talk about specific risks. We want to eliminate the fires. I don't want to get paged when things go bad. We want to maintain the trust and credibility we have with our colleagues, with our executives, with our customers and clients. And that comes with having high quality data products. We also want to codify our knowledge and assumptions. As we're working in a domain, we're working with data, we are learning a lot about how that data works and what's in that data. And oftentimes that lives as tacit knowledge in people's minds. So we have all these risks that we want to mitigate and codify. So let's talk about two very specific types of risks that we're going to mitigate. The first type I call pipeline risks. These are, in the plumbing. Something in the plumbing has gone terribly, terribly wrong. Missing files, empty files. You've gotten that call from the vendor. It's like, oh yeah, we delivered the files. They're on your FTP site. Well, sure, but they're empty. Mangled loads, corrupted data, schema changes, outages, unexpected values. etc. Let's jump back in here. And all of these are specific flavors of pipeline debt. So there's another kind of risk that lives in our pipelines. Now, the pipeline risks are really the job of the data, a stereotypical data engineer, to make sure that what comes in goes out of the pipeline, transformed in the correct way, and so forth. But there's another type of risk that lives in these data products and pipelines, and these are data risks. So these are things that data scientists care a lot about, and your customers might care a lot about. Distribution drift. If you've got models in production, those models have certain assumptions, and if those are not met, they're happy to go and make predictions and do wild, surprising, bad things generally. Data evolution, the meaning of your data may change. You can have edge cases. You want to make sure you are unbiased in your analytics and data products, outliers, etc. So these two specific types of data. I want to pause for a minute and see what questions you all have, or reactions, or thoughts, when you can now look at yourself in the mirror in the morning and think, as a data engineer, we've got a ways to go to catch up to where software engineering was or is. Let's see, where's the chat window? There we go. No questions. All right, we'll move on. We'll stop for questions again in a moment. Okay. So, what are we going to do about this monster that lives in our data pipelines and data products called pipeline debt? Well, we propose that you try this. This is our Python package. It's an open source Python package. It was started in 2017, so it's been around a while. And our slogan is you always know what to expect from your data. So what is an expectation? That's really the central point of Great Expectations. Well, an expectation is an assertion about your data. These are declarative. We really believe in making this easy for humans and machines. So we've chosen a very opinionated declarative approach. There are almost 50 expectations. And if any of those 50 don't meet your needs, you can create your own custom expectations to meet your domain. So let's just look at a few so you get a flavor of what these look like. We'll start at kind of the bottom to make sure that is the data there, and then we'll get more advanced. And I've just picked out a handful to look at. Expect file size to be between. So if you're working with files, you can write expectations that test the size of those files. Expect table row count to be between. Again, these are very, very declarative, descriptive statements. And these are Python functions that you call on your data, and we'll show that in the demo. Expect column to exist. I mean, who hasn't broken something by me when a column went missing? Expect column values to not be null. So again, more nullity availability checks. This one, while it seems really basic, this can have dramatic impacts on data products. As your missingness changes, it can do bad things to your data products. Expect column values to be unique. Expect column values to be between. Expect column values to be in set. Do you see a pattern here? Declarative, descriptive. Expect column values to match regex. So we have some more advanced ones where you can do lots and lots of things. When we get to distributional or aggregate expectations, we can do things like mean, quantiles, median, etc. If you want to get really advanced, and machine learning practitioners love this expectation because this is all about comparing distributions of value sets. KL divergence is a measure of distributions of how similar or dissimilar they are. So there's many, many, many more of these. And again, you can create your own if you need to do that. So how does this actually work? Well, expectations are written in Python, and they're executed on the back end on what we call compute engines or validation engines. So if I write an expectation on my laptop with my little demo data set or my anonymized data set that I'm using, I can take that expectation and then apply that in production against Spark or against common relational databases such as Redshift, BigQuery, Snowflake, Postgres, etc. And what's happening is that Python expectation is being compiled to native code. So for example, compiled down to PySpark code or Pandas code or a SQL query that's then executed on the computation engine. So we're not moving data around. We're moving the compute to the data. We're only bringing back metrics, and that's a pretty important thing because it allows the compute engine to handle the optimization. All right, so this is one of our just absolute core tenets, that tests are docs, and docs are tests. Now let's look closer at this because this is pretty phenomenal. So everything in Grid Expectations is a JSON. So when you write an expectation suite, that's a conglomerate of expectations, like a test suite would be in software. We write expectation suites. That's a JSON file. You store that in your source control, and then we can do really interesting things. So that's great because the machines can read that and so forth. But we take that JSON and we can compile it to HTML, which is what you see here. I'll show you this in the demo, but you see a visual representation of those JSON artifacts, which is so great because you can share that with someone and say, hey, our data is changing. It's not meeting our expectations. And here's what it looks like. The other phenomenal thing is that as long as you are running your tests, and you're running your tests, right? Right. Your docs cannot get stale because your tests are your docs, and your docs are your tests. Now compare that to the world that we live in for the most part, and it's, oh, who's got that latest data dictionary? Oh, it's on the wiki, and there's a version, and someone's got a spreadsheet, and latest data dictionary _A _ latest for sure. This is it, and you pass these things around. But this is embedded in your pipeline, and you know that your docs can't get stale. So we've looked briefly at Great Expectations. Now let's talk about how you actually crush pipeline debt using this tool. All right, where do we start? So in any data pipeline, there's a few places that are high risk. One of those is data ingest. When that data first hits your premise, this might be from a different team, it might be from a different company, it might be from something user generated. That's a great place. When you don't have control of that data, that's a great place to write expectation suites and tests. Before and after ML models, oh man, we've got some great stories about how this can help prevent machine learning disasters when you deploy things without protection. Analytic warehouses are a fantastic use for data tests, because not only do you want to be data-driven, you want to be good data-driven. You want to make sure that those business decisions are made on good quality data. And then my favorite is the dashboard table. You don't want that call from the executive that's angry. Why is the dashboard broken for the board meeting? And that just helps you maintain your credibility. So let's look at how you might do this in detail. We found this great little pattern buried in a Netflix presentation called WAP, Write, Audit, Publish. And here's an example of how you might use this in a pipeline. We've got some source data, we do some transforms on it, we validate that data using Great Expectations. Depending on the outcome of the validation, we would do something. We would either delete that transformation, that's awesome. There's some quality checks right there. We would delete that transformation, or we would publish that transformation. And then, of course, we would log the metrics, and we could notify and so forth. So this is kind of like the simplest version of how to put Great Expectations in a pipeline. You can obviously get more advanced and do things like multiple stages. If you have a transformation that's extremely compute intensive or very expensive, you may want to validate that data before you run that computation and so forth. So let's jump in. We've thrown a lot at you and see what questions people have. All right, Fitz, is GE able to interpret schema files as expectations? That is interesting. We did some early work on that, but not natively, no. I would love to chat with you to see what you mean by schema files, because that means a lot of different things to a lot of different people. But let's talk about that. Does anyone else have other questions?
Yeah, I wouldn't mind asking, what's kind of the reality of it when you have massive data sets, when you start getting into aggregations? For example, you were talking about running something over on Redshift, say, or in a RDBMS. If you're at several terabytes to be able to do medians and things like that. That's going to get kind of expensive. Is that what you see of users using it, or do they not test those kind of things as frequently?
That's a great question. So essentially, you're asking, what's the trade-off, right? Because there's a trade-off with everything, and depending on, and this is there's no right answer for this. This is depending. The answer is, it depends what your data product, what level of quality versus what level of cost you want to use. Now, anecdotally, we have worked with a number of clients with very large data in distributed systems, and almost all of the people we've worked with in those situations, that's one of their first concerns. Like, whoa, wait, what is this going to cost me? And what we've found is that the costs are nowhere near what people imagine. Furthermore, the benefits that teams have gotten in terms of time savings, in terms of bug problems, in terms of delivering bad things to the customer, have been well worth the cost. So I can't give you any hard numbers.
Okay.
But yeah, I mean, you can certainly write expectations that would be very inefficient. But it's kind of up to you to decide how to pull those levers. Really good question.
Awesome.
Okay.
Thanks.
Mark asks, let's see, I missed one from Angel. How do you recommend selling and prioritizing data quality hygiene when managers want to get more visible wins? Hypothetical manager, yes, of course. This is a tough question, is how do you really prove that this can save you time? And I hope you'll see in the demo today, the amount of time it takes to write one of these suites and deploy it is hopefully a lot less time than you will take debugging a problem once you have a problem. So I'm going to answer that in the demo. And there's another question. Mark is asking, is it able to have an expected distinct count of a field that should match a specific yet changing daily number? Yes. So we do have a quite nice pattern called parameterized expectations. So if you have if you wanted to write an expectation that relied on an upstream evaluation that changed, you can link those together. And we do have, I won't be showing that in the demo, but I can link to some docs that show you how to do that. But it's pretty awesome. It allows you to kind of reference variables discovered as metrics earlier in a pipeline. Okay, well, those are fantastic questions. So let's cruise on, because we've got some really fun demo to get to, which is now. So here's what we're going to do in this demo. We are going to set up Great Expectations. We are going to create an expectation suite. And we're going to edit that suite so you can see what that workflow is like. And we're going to deploy that suite. So this is going to be really interactive. Please jump in with questions in the chat or audio as we do this. All right, so I have got a very small data project here. I've got some CSV files. Now this is obviously a demo project, so it's not going to be giant. It's not in the context of a pipeline, but we're going to do all those steps. So let's start out. So first of all, Great Expectations wants to live in your source control. Your pipelines are source controlled, right? Everyone say yes. I can't see anyone nodding, but I'm just assuming that everyone is saying yes. So that's good. All right. So we've got Great Expectations installed. Great Expectations uses a noun-verb syntax in the CLI, which is hopefully pretty familiar to you. So the first thing we're going to do is initialize project. And this is going to lay down in a small directory structure where things are stored. And we'll poke at a couple of those in a moment. So let's say yes, and we put this in source control and a branch and so forth. And then it's going to say, hey, let's connect up a data source. For tonight's demo, we're going to use some CSV files on our file system. We're going to use pandas. All right, so I've got data, and let's use this NPI file that is a healthcare file. This is National Provider Identifier. It's commonly used for insurance and billing and so forth. And we're going to call this demo. When you first set up Great Expectations, it currently runs you through a little demo, and we'll just look at that right now. So it is going to pick a couple of columns. These aren't going to make, just to show us a little bit of the power of what Great Expectations can do. So under the covers, it has created an expectation suite, evaluated against this data, and then compiled that to these data docs. So this is this is an HTML visual representation of our expectation suite. So let's look at this for a moment. So we've got one expectation suite. And we've got one validation against that CSV. 14 expectations. If we wanted to see more details, there's plenty more details there. But let's look at some of these. Okay, so it's made some table level expectations. Must have exactly 71 columns. Must have these columns in this order. I use this expectation all the time because I don't want to be surprised with schema changes. So this is a pretty wide table. Let's look at a few of these. So values must not be null. It's done some min maximums. This is essentially a primary key, and the little demo thought it was interesting to do stats on it. That's not helpful, so we're going to throw that away and do something more interesting. But we've got some graphs and so forth that show you what some of the data looks like. So just pause for a moment on that. Not only is grid expectations good for data testing, but it actually, in fact, it was originally conceived as a helper for exploratory analysis. So as you're going and diving into a data set you've never seen, you can codify what you learn as expectations, and then you have a test going forward. So in that way, it's almost like test-driven development if you've done any of that. So let's get rid of this demo, and let's actually write ourselves a proper expectation suite. So suite, and I'm going to delete that demo suite. Get out of the way. Great. So we have a few operations we can do with a suite. We can make a new one and then write it all ourselves, which we would be writing those Python methods. But we've got a brand new feature that I would love to show you tonight called scaffolding. And this helps you write a bunch of boilerplate expectations and gets you off the ground faster. So that's what we're going to do tonight. So we're going to use this scaffold command. We're going to call this NPI so that I know it relates to that data table. Jump in the chat here, make sure there's no questions. Okay, so it's going to ask us for some data. Now, we're going to use some Jupyter notebooks that were compiled. And this is going to help us write an expectation suite. We don't need to go through this code. This is boilerplate. We have a little preview of our data set. This is where things get pretty interesting. So here are the 70 some odd columns in this data set, and I'm going to configure this this is going to do some like data profiling to help me write some expectations. And I'm going to choose a couple of these columns. Let's choose credentials. Let's choose gender. Whoops. Let's choose entity code. Beneficiary. Choose average age might be interesting to look at, and average risk score. So I'm now going to run this scaffolder. Now what this is doing under the covers is it is using some profiling that looks at, okay, so this is not going to be a production suite. It's not a very smart profiler. It uses some simple heuristics based on data type and cardinality and provides some suites for us. So it's written a suite with 28 expectations. Let's just glance at it, and then we're going to dial it in and really get it ready for production. Okay, so it's written 28 expectations. Again, we see some table level expectations. We'll probably leave those. And let's look at some of these other ones. All right, beneficiary average age. So it has done some nullity on there. It has put a distinct value on age, which doesn't make any sense. So we'll chuck that, but that's easy to do, and you'll see that in just a moment. And let's look at some other columns here. It's done some statistics on one that is this is our risk score, and we might keep some of those if we want to make some assertions about that. And then we're back to our, oh, now this is interesting. So our primary key actually has some unexpected values. We would assume that would be unique. And yet there are some that are not. So this is kind of cool because grid expectations actually shows you things that it finds. Now I'm seeing a question here. Is there a size of table that is too big for grid expectations? Not that we have found yet. Now I can't make any promises on that, John, but we haven't found one yet. So we are actually, and this is a great example of what we call a data surprise. When a person starts to write data tests, oftentimes we find that our assumptions about our data, that even data we know well, aren't true. So this is something that I might go back to my domain expert or my vendor and say, hey, I found something here that doesn't make sense. Now it's only a small fraction, 0.1%. but it is something we want to check out. Some credentials. Let's see. This is fun. So there's a column in this called entity code, and these are inpatient or outpatient providers. And you can see there's a distribution, and that might mean a lot for our data product, or if we're doing machine learning, and that's an important feature, that is going to be critical that these distributions, that we keep an eye on these, and so forth. We've got some gender in here that's interesting. So we have some expectations in here that make sense. There's some that we want to adjust, and there's some that we want to get rid of. So let's press this button now. We can close this. We're done with this notebook. We can close this. We can kill this notebook server. We will jump back over here and edit this suite. Now, if you forget what the commands are, there's a handy dandy little giant yellow button that shows you how to edit this suite. We paste that into our command line, and this is pretty neat. So we have, actually, before we dive into this, I just want to show you a little bit of what's happening here. This is our project. If we look in the expectations folder, here's the JSON that is the actual source of truth of this expectation suite. And we can see through this, and it's there. And you would commit that to source control, which makes PRs really excellent. Hey, I changed this table. Here's our new understanding of the data. It makes it really easy to do PRs and things like that. Pull reviews or pull requests and so forth. So, but this is not a great way to edit something. Much like you would not write a SQL query without access to data, you're not going to want to author or adjust expectations without access to data. So that's why we use this expectation editor. And this is, again, compiled right from that JSON file. It'll load up our data. And we can now author expectations. So now you see the actual expectations. So when we go to data docs and we see this HTML representation of this must have this many columns, this is the function that actually creates that expectation. So we may want to adjust that. Let's say in production, I know that this table should have anywhere from 5,000 to 20,000 records. Now, when we execute this, it's actually going to execute that on the back end and bring us back some metrics. So let's shift enter and operate that cell. And we see this object has a property called success. So that is actually true. Not only that, but we also have an observed value. So if we want to adjust this, we've got immediate feedback, which makes it really fast to adjust these things. So I'm going to cruise through a couple of these, and we want to keep those. And let's do this MPI column. So I expect the columns the values in this column to be unique, which we found that they are not all unique. Now, this is where I want to pause for a moment and talk about how software testing is different than data testing. In software, if I'm writing a function that does some little transformation, my test is going to be true or it's not. But that's not how data pipelines work. I mean, data is fluid, it changes, there's outages, things happen. It represents the real world. So our tests need to also have some flexibility to them. They can't be so rigid that they break. So let's imagine that in my data pipeline, I talk to my domain expert and says, you know what, it's actually totally normal for there to be some dupes in here, but not very many. So many expectations have a parameter called mostly. And this is pretty special because this allows us to define an expectation and give it a little bit of wiggle room. So let's say, hey, as long as this is 99% true, let's let it pass. So we now see that it is passing. It does give us some feedback. There's almost 0.2% that are duplicates. But you know what? For my pipeline, that might be fine. And I'm just going to move on. I do want to make sure that they are never null. Okay, great. They're never null. Success true. And all these statistical ones, I don't really care about because it's an ID. Let's get rid of those. Get rid of that unique one. And let's say we want to have, I don't know, 80% of these credentials not be null. So you kind of get the point of what of how you edit these expectations. It's interactive. You're interacting with that data and codifying those assumptions and making them more crisp and clear as things go along. Let's do this one. This will be fun. So I expect the column values to be the length of the string in this column to be, let's say, between 1 and 10. Ah, okay. So there are some highly credentialed people that have a lot of credentials. So let's go and adjust that and say, all right, how about 20? Great. That's fine. And we can go through and do some, you know, we're going to leave a couple of these and we'll say they're pretty close. Let's see. We do want to keep this distribution one. I think that's interesting. Let's make this a little easier to read. And we'll call that, say, 45% and 55%. And it's evaluating as true, and that might be good enough for what I'm trying to show today. So this is editing some of the expectations that our scaffolder built for us. What if we wanted to add a new expectation suite, or a brand new expectation? We can go to our glossary and kind of look at a couple of these. So this is the list of built-in expectations. There's around 50. And we can see, oh, let's do this one. Expect column values to be in set. And let's just make a new cell. So it needs to be batch.expect column. We can use our Jupyter autocomplete to kind of help us out here. Okay, so be in set, that's what I want. I need to give it the parameter. I want to use the column states because I want to make sure that this is only representing the US. And I happen to have a list of state abbreviations prepared. So you don't need to watch me type 50 abbreviations there. I'm going to pass in that list to this expectation. And of course, you've got docstrings here to help you out and so forth. States. So let's evaluate that. Ah, okay. There are 21% of these that are not in this set. Looks like some NAs with some spaces, some must be Guam, some NAs without spaces, and so forth. Now, for the purposes of the demo, I'm going to say, you know what, maybe that's just fine. So let's just say mostly equals, as long as it's say 75% in that set, I'm fine with it. Great. Now it evaluates as true. But you can kind of get the sense of like this can actually teach you about your data as you're codifying your assumptions. So let's get rid of this one. And let's cruise through and call this suite good enough. We'll get rid of that one. Values. Let's get rid of these stats on here. Actually, let's leave the median. That could be fun. Let's say I want my median to be between 2.4 and 5. Sure, great. So I have now spent a little bit of time. Maybe I'm sitting down with my domain expert and I'm codifying these assumptions. So let's save this expectation suite. Right now we're just in memory, but we do want to save those changes. And to make life more convenient, it's also going to rebuild that Datadoc site so we can see those again represented as HTML in a nice visual way. Oh, look, there's that distribution of entity code, and there's a distribution of gender and so forth. So we now have a pretty decent suite. Let's go and deploy this thing. Because this is where we're data engineers. We really want to know how this is going to save me time and pain, right? So I can throw this notebook away. Don't need that guy. And let's kill this notebook server. Now, how do you deploy this? So an expectation suite does not actually relate to a specific piece of data. So we need to combine an expectation suite with a description of data, a batch of data, smash those together and get a validation. And we're going to use that. We're going to use a new feature called checkpoint. And a checkpoint lines an expectation suite up with a batch of data and makes it very easy to deploy this in a pipeline. So let's do checkpoint new, suite list. Just make sure that we have a suite. Okay, I'm getting a question here in the chat. Let's see. Oh, yeah, so 2 questions. So Matt asks, what about the opposite end of the spectrum, small data sets, but need to have very low and tight response times, API-based interactions? Oh, this is interesting. So small data sets, like how small? Are you talking like 1 row? And I'm curious, how low of a response time do you need? If you're talking about 50 entries, yeah, no problem. That would be handled in memory and pandas, piece of cake, pretty fast. Ooh, 5 milliseconds? I'd have to think about that. That's going to be pretty tight. That's going to be pretty tight. So if you're doing super low latency, financial stuff, high frequency trading, like this is not the tool for you. But we should time some of these things to figure out if we're anywhere near that. Jim asks, how does this workflow change when you move from a CSV that fits on a single box? Ah, yes, but to a pipeline that runs on an EMR cluster. So this is great, great question. Expectations, because of the architecture, are a suite is generally portable. Now there are some exceptions, but not a lot of those. Portable to backend. So this suite I could then execute against my data set on EMR or on Glue or running in Databricks or whatnot. So let's an excellent question, by the way. So let's work on deploying this using checkpoint. When we make a checkpoint, we need to have an existing suite. So the first argument is a suite name. The second argument is the name of the checkpoint. Let's call this, I don't know, staging. Maybe this is a CSV I'm going to load into my warehouse. Oh, I've got them switched. So staging is the name of the checkpoint. MPI is the name of the suite. Let me use this data again. Now this is just made a checkpoint, just so you can see what a checkpoint is. A checkpoint, stored in source control, is a little tiny YAML file that connects the data with the expectation suite. This can be as simple as a single batch of data with a single expectation suite. It can be far more complex if you need that complexity. Maybe you have some teams like tiers. They have a suite that describes, like, the bare minimum. The data must at least not be complete trash. And then they have a higher level expectation suite, and they can do these in kind of tiers. You can also have multiple batches of data in here from different data sources, but for now, we're going to keep the simplest possible thing in mind. So let's run this validation. Great expectation checkpoint, run. Staging is the name of it. Now, if your pipeline happens to have shell access, your orchestration engine like Airflow, you could easily wrap this command in a bash operator, and you would have a great expectations deployment ready to roll, because this returns a POSIX code and be very easy to wrap that in Airflow. So validation succeeded. Now, what's happened is it's gone and run that, and then again, if we go back to our Datadog site, reload this, and we should see a new validation. So this is the one we just ran with our checkpoint. But let's make things a little more interesting. Let's add a Slack notification to our project. So this is the main project config file. We're not going into details here, but I am going to add a Slack notification. By the way, we have a pretty nice system for keeping your secrets separate from your configuration. So those live in either a file in the uncommitted directory or in environment variables. And that generally takes care of most people. So you'll notice I've got the Slack here, and off screen, I'm going to paste in a super secret webhook. Into a separate file that's not in source control. Okay, we'll paste that in here. Slack, paste. All right. So now let's run my validation. But I'm gonna do something even more interesting. So let's say that now I'm a vendor that you're getting this MPI data from, data/ really bad. And I've just dropped you a data file that is not so great. Let's see what happens. Pull Slack on screen here so we can see it. And we're going to run this validation and see what happens. Oh, look at that. I just got a Slack notification. My validation failed. It gives me some details, some run IDs, which you can configure, a timestamp, and then a little summary metric. We do not send any data into Slack. We only send very generic metrics because we're pretty serious about data security as well. So that's great. Hey, I have now turned myself into an extremely proactive data engineer. So that shows you how to deploy a checkpoint. If you have an orchestration engine that, well, let's go look at how I failed. This is the fun part, right? So why did this fail? We pull up our Datadog site and look at the failure. Okay, we can also filter these just to the failed, so why don't we do that? So there's some problem. There's a column missing, I'm guessing. And we have some things that are different here. Now this is fun. So entity code, we expected it to belong to an I or an O set. And it looks like, if we look at that, there's some data that has a space in it. So great, we can either adjust our pipeline or complain to the vendor or so forth. Not only that, but the distribution is different. This one has far more outpatient providers in it than our usual. Now for our data product, this is a big deal. So this is something we would want to investigate. You know what? It turns out also gender is more null than we hope to see. So by using data docs, it allows you. It really shortens your debug cycle. So instead of a week later finding out that something went wrong, I know at runtime that something changed with my data, and I can share this and with a data expert and say, hey, what's going on, and go from there. So I want to show you one last feature of checkpoints. If your pipeline orchestration engine does not have shell access, you can also do this via Python. So let's do this staging. I'm going to generate a Python script using this checkpoint, and let's look at what that looks like, just so you can see it. So if you wanted it, it would be right here, run staging. Here's 20 lines or so of documentation, 20 or so lines of code. It loads that checkpoint, loads some batches, and then here's the stuff that you really care about is what do I do? If it succeeded, do something. If it didn't, do something else. And that's where we really try to not be opinionated about what you do, because what you do is up to your pipeline. So that's how to deploy an expectation suite. So thrown a lot at you. Let's see if there are any other questions, and then we'll kind of wrap up. All right, Mark says, are checkpoint notifications via email a native function of Great Expectations? Mark, they are not. We would love to have a pull request. That would be a phenomenal thing to add, and other people have asked for that feature. However, it would be, if you have a Python library, it would be a simple thing to add yourself as well. I want to wait for a minute to see if anyone has any audio questions. Okay, no questions coming in. All right, so let's just recap for a moment what we've seen tonight. Okay, so we have seen an expectation suite made. We set it up on our project. We did some boilerplate. We kind of honed it to make it tight. We deployed it in our pipeline, and we can take some action on it. So in a short amount of time, we can get that into our pipeline. So I want to spend a minute and talk about how we can work together on this, because all of us have data quality problems, and why not work on this together? So here's some ways that we work with people. Obviously, we have an open source Slack channel, which links are in that document. We have almost 900 people in that channel now. It's getting pretty lively, which is really, really fun. Along that, we dedicate a person every single week. We all rotate through to answer questions that pop up in Slack and other places. So if you want to talk data quality, hop on our Slack channel. It's lively. We're having a ton of fun. You can collaborate with us on GitHub through pull requests, feature requests, etc. We're getting a ton of community engagement there, and we'd love to engage all of you as well. The other thing that we offer teams is something we call, not a great name, but it's fun, a deployathon, where, and this is free of charge, this is open source. We just really like working with teams, where we will work with you for a half a day or so, or a couple hours, to try and get Great Expectations set up in your pipeline. We also offer consulting services. If you're interested, we can talk later, but we are really focused on making Great Expectations the data quality library. So here's a couple links. I would love to see if anyone has posted any more questions or any data scary stories. We do have some scary stories. That's awesome. Okay, we'll look at these. Let's see. We're going to open this up to questions. What questions do you have about data quality?
All right, this is Joe. What are some of the scariest things that you've seen? Not to name names, of course.
Not to name names. Scariest things I've seen. This is always a fun conversation. We have seen, the executive dashboard story is a real story. Getting that call really ticked off executive. Board meeting is shortly, and the dashboard that is going to be raved about isn't working. So that's a crisis moment. Certainly other things where we've seen machine learning models in production doing unholy things because they don't judge the data. They just happy to make predictions on things that they shouldn't, and that's why we like to protect these things with expectation suites on either side, and all sorts of other things. One of the greatest stories that we've seen is where you go from where a team implements this, and we hear this story again and again, where you go from a very reactive, stressful workflow of responding to crises because you don't understand what's happening with your data, to a proactive workflow where it's like, oh, there's something in, hey, last night's batch was different. By the way, downstream users, we're already on it. We know what's going on. We will have a fix shortly. Just give us a couple hours and it'll be fixed. So it's really neat seeing teams make that transition. There is an activation energy. Once you get over that, it's pretty awesome. The chat window keeps disappearing. There it is. Cool. Well, I'm going to stick around and would love to just chat with any of you about data stories or things you've seen. Oh, in the links I shared, there's also a example pipeline that uses Airflow, grid expectations, and DBT. If you haven't used DBT, oh man, you need to use it. It's so awesome. But that's more of a real world example of a real robust pipeline. Let's see, there's a question. Is there a way for GE to give feedback on confidence in data quality? Some people, that really is such a subjective thing. And if I can soapbox for a moment, I'm kind of tired of us, and by us I say data engineers and data science people, complaining about bad data. Oh, the data's dirty. Oh, blah, blah, blah. You know what? I think things are more nuanced than that. And instead of saying bad data, we really like to think of it as fitness for purpose, because maybe this chunk of data is great for retrospective analytics, but it's not good for prospective analytics. So we really try to think of things as fitness for purpose, and having an expectation suite that communicates that purpose allows you to make those decisions in a clear way. Cool. Well, that's all I've got. I'll stick around, and it's great to see y'all. Thank you.
Yeah, thanks, Taylor. Everyone give him a round of applause, however that works these days. Awesome.
I do need to ask for one more thing. Instead of a round of applause, hop on GitHub and give us a star. I'm going to shamelessly beg for that. This is something that helps us tremendously. It keeps our investors very happy to see those star counts going up. It kind of boggles my mind that that's a metric that they care about, but they really do care. So help us out and give us a star. That's the applause I would ask for.
Do you guys have any notion of extending this to streaming data at some point?
Yes.
Examples there, so I'm not sure if you're already there or if you plan on doing it. So
yeah, we have teams thinking about it. It's not currently on our short-term roadmap. What we have seen people do is hook this into a Kafka stream or something and make kind of small batches. Now, again, if you have super low latency requirements, this may not be the right answer for you, but and we don't have anything native that works with streaming, but that is something that we hear about, and there will be something in the future for sure. Or submit a PR. But yeah, micro batches on Kafka does work. We've seen it.
cool. Just gave you a star, by the way, so hopefully your investors are
Thank you.
gloriously happy now. I guess to open up the conversation, I mean, what are some of the data horror stories people have seen out there to kind of reiterate Taylor's question? So where would this be useful, I guess, in your experience? Asking the general audience, of course.
So one thing that happened today to us is a table that was supposed to have data in it for a certain enterprise IAD had no data being populated. And the DBA, he knew about it. He didn't tell us until I think 9 or 10 a.m. But if we had had this in place, we would have known, and we wouldn't have had the customers coming to us and saying, "Where's our data? There's no data for today. Where is it?" And so, yeah, it would have we would have been able to proactively reach out to our customers and say, "There's no data. We know. We're looking into it." Instead of having them find the defect, we would have found the defect. So it would have been nice.
Yeah, that's a great story.
Sorry. Sucks. Yeah, it sucks when like users or your executives end up being the QA team for your data. So
I know, I hate that so much. I wish we had a power user group that would look at things first, but the way we deploy, our customers see it, and there is no QA between developing and customers seeing it. So this could be like a QA spot.
Yeah, we've seen a lot of teams save so much time, data product teams using this as QA, and it's really helpful for that specific case. By the way, I've got 2 data story submissions. Hit me up on, let's see, hit me up in chat so I can get you some swag.
I guess in terms of deploying this, what's your recommended setup? Actually, just like a simple EC2 server, or like how do you generally deploy this?
Yeah, the nice thing about it is you don't need a lot of resources to run Great Expectations, since the compute's all happening in your database or your Spark cluster or whatnot. So yeah, we see people doing it on EC2. We see people putting this in their Airflow pipelines or just general scripting. We also see people that maybe are more on the data science side that don't have either access or ability to modify the pipelines themselves. So they'll just run their own checkpoints kind of on the side. And as long as that data is materialized somewhere in a database or something, it's very easy for that practitioner to get the benefits before it's truly embedded into a pipeline.
Oh, cool. If there's no more questions, I'll stop recording and then leave it open for networking and general chat. So I'm going to stop recording right now.